In this video, I'll go over test 1 from M138, spring 2013. Problem 1, find the following limits. The first limit as x approaches 1 of 3x squared minus 6x over 2x squared minus 8. You just replace x with 1 and you get 1/2 after simplification. Part B, limit as x approaches 2 of the same function. If you replace x with 2, you get 0 divided by 0, so you have to simplify your function before evaluating the limit. You factor the numerator and the denominator, and then we notice that there is a common factor in the numerator and the denominator, x minus 2, x minus 2. You simplify, and then you plug that 2 in, and you get 3 over 4. Part C, limit as x approaches negative 2 from the left of the same function. So if you replace x with that negative 2, you'll notice that you get some finite number in the numerator and 0 in the denominator. So that's one of those infinite limits. Now, since I'm working with exactly the same function, I'm going to simplify it the same way as the line above over here. So I'm going to work with the factored form. Simplify x minus 2, x minus 2 to decrease the numbers. You don't have to do it. And then 3x in the numerator approaches negative 6 as x approaches negative 2 from the left, and the denominator approaches 0 from the left. Since x approaches negative 2 from the left, x is going to be smaller than negative 2, which means that x plus 2 is going to be smaller than 0. So you get negative 6 in the numerator, then 2 times 0 is 0. So 0 from the left in the denominator, so you have negative over negative gives you positive, and infinity, because a finite number is 6 divided by a really tiny number close to 0, it grows up to infinity. Part D, limit as x approaches infinity of the same function as above again. If you just plug it in, you get infinity over infinity, no good. So you divide top and the bottom by x squared, x in the highest power of the denominator. And after you split these rational expressions and simplify each, you get 3 minus 6 over x, and then in the denominator 2 minus 8 over x squared. So these little expressions 6 over x and 8 over x squared approach 0 as x approaches infinity, which means that our limit is going to be 3 minus 0 over 2 minus 0, just 3/2. Part E, limit, let me just move this down here. Limit as x approaches 0 of the square root of 1 plus x minus 1 divided by x. If you replace x with 0, you get 0 over 0 undeterminate form, so we need to simplify our function somehow. And in this case, we multiply by the conjugate, top and bottom. So you have square root of 1 plus x minus 1, you multiply by the square root of 1 plus x plus 1, top and bottom. And then if you multiply the numerator, so you just FOIL it, you get 1 plus x minus 1, and then you keep the denominator in factored form. So x times the square root of 1 plus x plus 1. And then you see that the ones in the numerator simplify because it's 1 and negative 1. And you're left with x in the numerator. X is also a factor in the denominator, so you can simplify it. And then after you simplify it, replace x with 1 and you get 1 in the numerator and 2 in the denominator. F, limit as x approaches infinity of 2x cubed minus 1 over 4x squared plus 3. You divide top and bottom by x squared because of the denominator. The degree of the denominator is 2. And after simplification, you get 2x minus 1 over x squared. And in the denominator, 4 plus 3 over x squared. And as x approaches infinity, 2 times x will approach infinity as well. 1 over x squared will approach 0. 3 over x squared will approach 0. So you have infinity in the numerator and 4 in the denominator. So infinity divided by 4 is still infinity. Problem 2. Sketch the graph of function f that satisfies the given condition. So you have limit as x approaches 1 of function f is 3. So that's a both-sided limit. So as x approaches 1 from the left and from the right, your function should approach 3. Now f of 1 is equal to 0, which means that you should put an open circle over here and a closed circle where x is equal to 1 and y is equal to 0. Then the next condition, limit as x approaches 4 from the left of function f is infinity. So this is x equals 4. As x approaches 4 from the left, your function should go up to infinity. And limit as x approaches 4 from the right of function f is negative infinity. So as you approach x from the 4 from the right hand side with x's, your function should go to negative infinity. Limit as x approaches infinity of f is 0. So as x approaches infinity, your y coordinates should go towards line y is equal to 0, and you can clearly see that they are approaching y is equal to 0, this x-axis. And then the last one, limit as x approaches negative infinity of f of x is infinity, which means that as x approaches negative infinity, your y coordinates should grow infinitely. So they are not approaching any stable number, any particular y. They just keep going up and up. Problem 3. Use the definition of the derivative to find f prime of 9. For the following function, f of x is 1 over x. Note, no points will be given if you use the power rule. So you need to use the limit of the difference quotient. So f prime of x is limit as h approaches 0 of f of x plus h minus f of x over h. And then f of x plus h is going to be 1 over x plus h. Notice function f of x is 1 over x. And f of x is 1 over x, then that divided by h. If you try to evaluate this limit, you're not going to get anywhere because you're going to get 0 over 0. So what you do is, well, I rewrote my difference quotient as 1 over h times the numerator, because if you divide anything by h, it's the same as multiplying by 1 over h. And then I find the common denominator for whatever is in brackets. See the common denominator here. And then expand the numerator. X and negative x cancel out. And then notice that you have in the numerator negative h. Then you have that h here in the denominator, so you can simplify them. And then you replace this one remaining h over here with 0, and you get negative 1 over x squared. Now, the derivative of function f is negative 1 over x squared, so I wrote it here. And the problem was to evaluate f prime of 9, so you have to replace x with 9, and you get negative 1 over 81, because 9 squared is 81 over here. Problem 4. Find the equation of the tangent line to the graph of f of x is equal to x squared plus 2 e to the x plus 3 at point x equals 0. Notice it does not say to use the definition, and it would be very difficult for you to find the definition, to find the derivative from the definition with e to the x. So you find the derivative, which is 2x plus 2 e to the x. The derivative of 3 is 0, of course. And then the slope of the tangent line is going to be the derivative evaluated at the given point, which is 0. That's why I wrote f prime of 0. So you replace x's with 0, and you have 2. That's your slope of the tangent line. Then the y coordinate of this point is not given, so we have to find it. So you replace x with 0 in your original function, so evaluate f of 0, and we get 5. So this is what you have. The slope of the tangent line is 2, and the point at which we have to find the tangent line is 0, 5. So you just put it together in the point slope form of the line. So y minus 5, y coordinate, is equal to 2, which is the slope, times x minus 0. And then you just solve it for y. Y is equal to 2x plus 5 is the equation of the tangent line.